Hello there. We are going to be writing about a RawVec. A RawVec, it's not a real thing outside of Rust. It's actually what the studlib calls their data structure that they use in order to kind of encapsulate the unsafe access that they use for VEC as we know it. So we're going to look a little bit at the studlib implementation, not the internals, because I don't want to just copy those when I actually get around to writing this, but it would be good to understand the interface that they're doing so that we make ours both like encapsulated enough but also like flexible enough, right? So what's the main purpose of doing the RawVec? Well, I guess we should just write, right? Instead of me explaining. That would be dumb. I'm just going to write it anyway. I need to change music. I have J-Pump on, which if you're watching this on YouTube, you have no idea because YouTube doesn't appreciate our music playing. But we have to switch from Sutomayo over to something I can actually write to, which lately has been my post-rock instrumental playlist. People like This Will Destroy You, Russian Circles, good stuff. Good stuff. All right. Yeah, move to K-pop. Yeah, I don't think that's going to be a big enough I don't think that's going to be a big enough jump for me. I think it'll still distract me while I'm writing. While I'm coding might be a different story. Um, you know, realistically my Japanese vocabulary is still currently at like 25 words. So, we're not we're not too we're not too far in the Japanese learning. Let's see. Shall we do this right now? Okay, let's talk about my Duolingo streak right now. I say I'm not too far, but it's because you have to learn the whole effing writing systems. 138. Okay, here I am. You can add me on Duolingo if you want. Oh dear, I can't even see if this is working. Oh, I still can't see. I'm being super boomer about this. Anyway, you can't see that, but 138 is my current streak on Duolingo for Japanese. Yeah, I've just finally gotten hiragana down, and that's about as far as we've gotten. About 25 words hiragana, and that's about it. Okay. You keep thinking about picking up English? Yeah. I don't like to do that. I don't I've done enough English in my life. I'm over it. I'm so bad at English now. I used to teach English. True story. I taught English at a small private school to junior high and high school students right out of college. I only did it for 1 year, if that tells you anything. Granted, I was teaching English like to Americans, but it was, English grammar and stuff like that. Anyway, enough about me. Let's talk about me. Let's do all this stuff. You found Babbel and Pimsleur more helpful, but Duolingo sure is addictive. Yeah. It's done something for me at this point. I'm going to stick with Duolingo for now, and then I can... Oh, I did figure out how to say the F word in Japan. In Japan. That's hilarious. In Japanese the other day, and I already forgot it. I figured it out, and then I forgot it. Duolingo does, but I actually wish I could disable that sound because it's so loud. It's so much louder than any other thing on the freaking phone. It's louder than the people talking, any of those things. It just has that sound, and it's like, oh, I got it right. Now, I will say when I get it wrong, which doesn't happen that much, it's just like it is soul crushing when I hear the "you got it wrong" sound. Pretty rough. Still not used to that sort of rejection and denial. You could never recall much outside of the app on Duolingo. Yeah. I mean, the thing that this is really important part of writing a RawVec, by the way, is talking about language learning. Of course, I'm like watching a lot of anime, so that helps some. And then I also follow a few Japanese tech people on Twitter, and then I read what they say, and then I translate it and all that kind of stuff. So like I'm trying to get more like some of that real world usage in, but we'll see how it ends up actually panning out long term. Who knows? Um, I did have an interview with a company based in Japan today, for a potential contract job. The hiring guy is actually French Canadian but lives in Japan. So that could be a cool merge of worlds. So we'll see if I end up doing some part-time contracting with them or not. Am I going to open sauce? I don't even know what that is, Juice. Merge the worlds, exactly. El Cimarron. El Cimarron. Is open sauce like some conf? Guessing that's what that is. I'm not going to this. I don't do confs. No, I actually am thinking of doing TwitchCon, as we talked about. Oh, it's in June. I might actually be there. I don't know. It's interesting. It's so weird. It's so weird that I'm going to be so close to San Francisco. Even though I don't have like any actual plans of doing anything in San Francisco. But we'll just do when I actually get the trip booked, you know. Then we'll make plans. But I might consider it. I might consider hanging out with you in Bad Cop if I'm actually in town. I mean, at the place. Like in general, if I come into town, I'll let you know. I'm not trying to be a jerk. I'll consider hanging out with you. Nice. Okay, let's see. We're probably 10 minutes into this video. I hope you're enjoying it, and we are going to start writing now. Okay, so what's the point of a RawVec? Let's see. So a data structure called a RawVec is used in the Rust stdlib. Is used in the Rust stdlib to encapsulate raw memory access. We'll fix this. This is just to get some ideas down. To encapsulate raw memory access and to encapsulate raw memory access. Let's see. What do I want to say? To encapsulate raw memory access, e.g., unsafe behavior. Unsafe behavior. Maybe we'll say unsafe logic. No. Encapsulate raw. We'll just say raw memory access for use. There we go. In Vec. Let's see where else it's used. I actually don't know. Does VecDec use the RawVec as well? I'm guessing that it does. Okay. So let's see. RawVec probably doesn't even come up because it's just an internal stdlib thing. What about a VecDec? That was slow. That was very slow. Okay. So let's see, what are we on here? We're on VEC. Okay, so VEC, as their buffer, uses a RawVec new. What does VecDeck use? VecDeck also uses RawVec. Okay, we're getting somewhere here. I'm guessing those are the only two usages of RawVec, but I could be wrong. Alloc, Vec, mod. Okay, where is this? VecDeck. Oh, I didn't know there's a B tree in the stdlib. That's cool. The things I don't know. Interesting. They're just using a vec. They're not using RawVec. Okay, we'll just say for vec and VecDeck. I think that's good enough. To encapsulate raw memory access for use in vec and VecDeck. Okay. Let's make this code. Let's make this code. Let's make this cold. Okay, a data structure called a RawVec is used in the Rust stdlib to encapsulate raw memory access for use in vec and VecDeck. So now I haven't looked at RawVec in a while, so I actually need to take a look at it. Where am I looking? Where is RawVec? RawVec comes from right here. Core alloc RawVec. I have not made a distinction at all in these posts between core and stdlib just because I don't think it's that important. And if you know enough for us to actually care about those things, you probably don't care about these posts anyway. So anyway, we'll just leave it as the way that we have it. Yeah, in the sidebar on the left. Thanks, Purplish. Yeah. Where is RawVec? It's right there. It's right there, Meta. Come on. Okay. So let's just look at this. Uninitialized, zeroed, sure, RawVec. Okay. So RawVec has a pointer, it has a cap, it has an alloc. Okay. The main thing that I wanted to look at is what they actually impl on this. So for the global allocator, they have new, they have with capacity and with capacity zeroed. For a generic allocator, they have a const, sure, pub constant function new n, with capacity n, try with capacity zeroed, try allocate n, capacity use size init alloc a, the amount of LVMIR generated, sure. From our parts, pointer, non-null, capacity, allocator, current memory, reserve, try reserve, reserve exact, shrink to fit. You almost banged on your monitor. Hilarious. It's right there. Look. Okay. So this is a lot of things about capacity and growing. All good. We got shrinking. Okay, cool. Okay, cool. That's what I wanted to know. it doesn't have anything all that special. The only function that I wasn't 100% sure about is this try allocate n. So maybe we read this real quick. Let layout equals match, layout array t capacity. Okay, layout, sure. So you get a layout, you have an alloc guard of layout size. Sure. Result. This is still just about allocating the actual contiguous memory chunk. Okay. That's all I really wanted to know. It wasn't about, it's just about allocating the memory. It wasn't about like allocating. Yeah, I don't know. It's not making a write operation or something. That's really my point. Okay, cool. I did not mean to go to Emacs. That's just out of habit. All right, here we go. Back to here. What's up, pizza? I'm pretty good. We're just writing about a little RawVec. I had to look at the implementation and the stdlib a little bit. At least the interface is really what I was going for, so I could actually know what it actually does. So what RawVec provides? So RawVec provides allocation, raw memory. See, it's not really raw memory access. So technically, because of just reading the source code right now, that means in VEC, like in the VEC implementation, they're actually doing the unsafe reading of a pointer into, you know, like a raw pointer into the actual data, like the actual type that the user wants. So that has to happen in VEC. Let's just double check that that's true real quick. What could we look at? Actually, that might be easier. If we go back to VEC, and we'll just look at Git or whatever. What do they call it? Oh yeah, it's the indexed thing. So it'd actually be in their, it's annoying because it would actually be in their we'll just look at pop. That'll tell me all I need to know. We'll look at pop. Okay, here we go. That's what I thought. They're doing the pointer reads right in here. Cool. That's what I wanted to know. To encapsulate, okay. A data structure called a RawVec is used in the Rust lib to encapsulate raw memory. So I'm actually going to say to provide raw memory allocations for use in VEC and VEC deck. Boom, growable. Raw memory allocations for use in VEC deck. RawVec provides. Ooh, now I'm kind of like second guessing whether this is how I want to do it. I think it is because ideally I just use this for my ring buffer and for my VEC, but we're not going to call it a VEC. So I'm going to call this a RawVec because I'm basically just stealing this from the Rust lib, but I'm most likely going to call my actual VEC implementation an array list. I'm pretty sure I'm going to do an array list. I think it's a good thing to do. It's either that or I'm just going to do a stack and a queue on top of a RawVec. Shouldn't you be borrowing it, not stealing it? Nice. Nice, Purplish. Okay, a data structure called a RawVec is used in the Rust lib to provide growable raw memory allocations for use in VEC and VECDEC. It has a very simple let's see. Making this logic reusable. No. Ugh. I'm having a hard time because it's like, how useful is this actual post? Like, what's the point? I'm having a hard time getting to the actual point of this post. What do I actually think is the point here? We want to talk about a RawVec is, what it provides. We pretty much just did that in one fucking sentence. What else do we want to say about it? Oh God. I guess we could talk about the idea of contiguous memory allocations. That's a good point. Okay. Contiguous memory allocations. What happens when they grow? Okay, good. How this differs from linked lists, since that's what we just finished talking about. So I think this is just going to be a really short post, is really kind of what it comes down to. So we want to talk about a contiguous memory allocation, what happens when they grow, and how this differs from a linked list. Pretty obvious. And then how it's used, maybe, but that's mostly, okay, what data structures we will make on top of this RawVec. Yeah, something like that. Yeah, I think talking about memory is really the point here, right? I think that's probably the most interesting part of the RawVec, is it's managing our memory allocations for us. So this is our alloc in systems talk, right? We have our alloc, and then our data structures are going to handle our reads, our writes, and our copies themselves. This isn't going to do any of that because that's dependent on how the data structure on top of this works. Okay, I think this is still a good idea. So what are we actually going to build on top of the RawVec? We're going to build an array list. We're going to build a stack. But I'm kind of wondering if we just want to skip the array list. It's either that or we write the array list and then I write the stack using the array list, because it's really not going to be all that different. It's just going to be like a small interface changed. So we'll just still say that it powers an array list, a stack, and then our ring buffer. Right? Array list, stack, and ring buffer. Cool. Anything else? I think that's pretty much the main things that I know I'm going to implement. A data structure called a RawVec is used in the Rust stdlib to provide raw memory allocations for use in VEC and VECDEC. A VEC an array list and so maybe we just say a growable array list and VECDEC. I knew that was going to happen. A growable ring buffer. Okay. Okay, cool. Contiguous memory allocations. Why aren't you back to non-weird text? Why did you do it? Why would I want to press enter and still be in a heading? Who wants that? Who wants to be in a heading when they press enter? I want to be back on paragraph. Oh my God. We're just going to type pi symbols. How do I get to normal text? Jesus. The most important feature of the RawVec is that it provides a contiguous memory allocation. Oh yeah. Confluence's editor is also extremely annoying. I just hate when people use like fake markdown. It's like they're like, oh yeah, we can use these couple things like markdown, but we're not going to support these other things. And then instead of like, this is the biggest annoyance I have with this editor because of what I'm writing. Instead of being able to do that, I literally have to select and click. Why would you not just support that? Like, it seems like more work to disable that feature of Markdown than it is to enable it. But obviously, it's not like they're just using Markdown underneath. Like, we don't need pseudo Markdown. Exactly. Okay. Today's Substack rant is over. The most important feature of the RawVec is that it provides a contiguous memory allocation. I don't know if this is actually true. Let's see. You came for the rant. Yeah, I mean, why else are you here, really? Memory allocation. This means if I use a... Okay. This means if we want to store 5 I64s in a VEC, the RawVec knows how to the RawVec does the job of asking the system, is this fine? Like I could say the OS. Yeah, it's fun to pile up on Confluence and Co. Yeah, for sure. For sure. I know it was really funny, like LinkedIn, of course, because I said like I'm open to work or whatever it is, which was probably a bad choice, but the market sucks right now. So it's just like, okay, if I get inbounds, I'll take it. So I said open to work on LinkedIn. And so then they send you these like job suggestion emails, and one of them was a senior staff software engineer at Atlassian. And I just couldn't, it was just this like weird path of thinking, like, what would it actually be like to be a SWE at Atlassian? It sounds like maybe they're just totally fun people that just make a product that sucks the life out of the rest of the industry, you know, but I can't imagine that that's true. That means if we want to store 5 i64s in a VEC, the RawVec does the job of asking the system for a memory block that will store those, for a memory block that will store these 5 integers in line. I think inline makes sense. I will store these 5 integers in a single chunk of memory. How about that? A little bit better. I guess we need to change the 5 to 5. Yeah, it's a blog post. I mean, we're writing. It's in the title, Amit. It's in the title. You know, I'm perfect about updating titles. I've worked with the senior support engine at Atlassian. He was a character, but also said that it's like super pressure. I can only imagine. Yeah. Docs and rants. Yeah, pretty much. That means if we want to store 5 i64s in a VEC, the RawVec does the job of asking the system for a memory block that will store these 5 integers in a single chunk of memory. But so let's see. I think that's a good paragraph. So what happens when we want to add a 6th i64? I'll just say integer. A 6th integer. The RawVec has to ask the system for a new chunk of memory. It could be the same chunk plus 1. It could be. I don't actually know how that part works. I haven't dug into that. But we'll just say the RawVec has to ask the system for a new chunk of memory that is large enough to store all 6 integers. This is the point of... Yes, it does double in size technically. I mean, you know, it depends on how you do it, right? You could call an explicit resize. Like if you knew, right, Gio, if you knew that you were only going to ever store 6 integers, you could ask for a specific resize to 6, right? If you were using the Rust lib. The RawVec has to ask the system for a new chunk of memory that is large enough to store all 6 integers. In practice, unless the new size is explicitly specified, it will double the original allocation. How about that? I like that. Yeah, Gio. How's it going? I feel like it's been a bit. Hope you're doing well. In practice, unless the new size is explicitly specified, I don't think we need that comma there. In practice, unless the new size is explicitly specified, it will double the original application. This is the point of using, okay. The RawVec manages the allocation The RawVec manages the allocation. No. The RawVec manages these allocations. I forgot what I was trying to say in this sentence. Amit says, you've been busy with an interesting project for that company to get the color from the images or videos. Ooh, that's cool. To put it in the background. It's like getting brand color from the media. You enjoy doing it. So I'm guessing, did you look for like the most common color in the background, or I'm sorry, the most common color in the image to choose as your background? Or was it something, did you use like a different algorithm for it? Geo, you've been writing your own simple P2P messaging lib, similar to lib P2P, but 1% of the code. Very cool. Awesome. In Rust, Geo, or what have you been using for that? Yeah, peer-to-peer, yeah. Despite me not being able to read it, I do know what it is. In Go? Cool. Yeah, with chunking for average. Yeah, that's what I was thinking about, is that, of course, like the colors may not be exactly the same, but you might want to take the average of it, right? Yeah, that's very cool. The RawVec manages these allocations. This growable allocation. So Vec doesn't have to. Okay. So what happened? Let's just read this section and see if it makes any fucking sense. The most important feature of the RawVec is that it provides a contiguous memory allocation. This means if we want to store 5 i64s in a vec, let's see if we like this. i64s in a vec. The RawVec does the job of asking the system for a memory block that will store these 5 integers in a single chunk of memory. So what happens when we want to add a 6th integer? The RawVec has to ask the system for a new chunk of memory that is large enough to store all 6 integers. In practice, unless the new size is explicitly specified, it will double the original allocation. The RawVec manages the growable allocation, so vec doesn't have to. Okay, I like that. Yeah, maybe I would. I don't know. I have an idea for what I'm actually going to do on Fridays now. I was trying to convince myself to write the YAML, the YAML format for OCaml Saturday, but I just couldn't. I don't think I can convince myself to do it. I'm just not excited enough about it. And that's unfortunately what I have to do. You extract dominant colors for video in a time series way with 10 samples. So when you run the video, the background changes. Oh, that's really fun. That's really fun. Well, I think you've done some really cool stuff with images. I really liked your image to ASCII converter. I thought that was very cool. Okay, so we got to contiguous memory allocations. We got to what happens when they grow. How this differs from LL. Yeah. Comparing to linked list. Okay. Now we're in normal text. This time enter just worked. Whatever. So vec doesn't have to. Comparing to linked lists. This contiguous memory block is what makes arrays and array-like, array-based data structures so fast for reading. So fast for reads and writes. Okay. I think this is fair. This contiguous memory block is what makes arrays and array-based data structures so fast for reads and writes. We'll talk more about this, the details of this, and you've also used code to generate Mandelbrot set, but code is lost in time. This contiguous memory block makes arrays and array-based data structures so fast for reads and writes. We'll talk more about the details of this when we talk about array lists. This is different from linked lists. Okay. Maybe I just am not going to say the sentence. So fast for reads and writes at the price of flexibility in allocation. Okay. The contiguous one makes arrays and array-based data structures. Okay. How about we just say array-based data structures so fast for reads and writes at the price of flexibility and allocation. For a linked list, we only have to ask the system for an allocation large enough for the next node. In an array, we need a memory block that will fit our entire list. Okay. In an array, we need a memory block that will fit our entire list. Let's see, is this clear enough? This contiguous memory block is what makes array-based data structures so fast for reads and writes at the price of flexibility and allocation. For a linked list, we only have to ask the system for an allocation large enough for the next node. In an array, we need a memory block that will fit our entire list. And in the case of a growable array, visibly, we'll say e.g. vec, and in the case of a growable array, e.g. vec, we also have to suffer the cost of resizing and reallocating. We'll just say resizing. Resizing this memory block. All right, so we will just say vec. They did that thing to me again. 1 hour second. Yes. What's up, Nightshade? And now we'll say, we'll talk more about the details of this when we cover array lists. Okay. Like I said, this is going to be a short freaking post, but I don't mind. So RawVec. Implementing RawVec. Okay. Any unsafe Rust code is like writing C, C++ code. Yes, you are not wrong. So I'll reread the thing in a second, because I'm almost done. Implementing RawVec. So the studlib implementation of RawVec handles a broad amount of use cases. For our purposes, we will just implement a RawVec with the ability to allocate and resize. Okay. We will probably do a sized allocation and a non-sized allocation, but we'll see. Since we're working with raw memory access and allocations, we must use unsafe. Okay. It's unsafe to leave it out. Nice. Good one. Okay. So to do, implement RawVec. My favorite part of these writing streams. To dig deeper into this code, and let's see. So we could talk about the layout. Let me think. Do we want to like go through the pieces? I think that part could be interesting, because basically we're going to need to talk about layouts. Okay. Okay, so that actually might make this post more interesting. We're gonna have to talk about layouts, and then sizes, which will give us a chance to talk about unsized types. And I don't know that much about allocators, so there is like a basic rule about allocators in Rust, and I mean, believe we're just going to use the global allocator if I remember right. So we finished this. Talk about layouts, sizes, unsized types. Okay. And then I think I'm just going to talk about this in the summary. So let's just write our summary real quick, and then we'll talk about this. Summary. By encapsulating the logic for memory allocations, we can now use our RawVec as a basis for a number of data structures. Array list, vec, same thing, stack, and ring buffer. Ring buffer, and more. I don't think I really have. I haven't really played with that. Ring, buffer, and more. This also allows us to reduce the amount of unsafe code in our data structures. Instead of re-implementing the allocation logic for each one. Okay, this is Rust. Interesting. I'll look at that in a second. This also allows us to reduce the amount of unsafe code in our data structures instead of re-implementing the allocation logic for each one. Okay. Da, da, da. Rust provides it's hard to do this without writing the code. So this one I'm gonna have to finish some of this work after I write the code. Write something about Rust's interface for memory layout, alloc sizes, etc. So we're just going to summarize the kind of to-do writings above, and then we'll talk about next time. I think it's to, what do you call it in C++, Amit? What do you call a growable array in C++? Is it just called an array? Or does that not matter because you guys just do all of the, you call it a vector, right? Okay. So I think technically, now I don't have a CS degree, several of you do. Technically, an array refers to, like a Rust array, an immutable contiguous list of items, right? So when we say array list, it's the same as a dynamic array or what they call an array in JavaScript, God forbid. So it really just means list. I think the reason people say array list is that they are saying it's an array-based list. I think that's the point. So that's the generic term I know it as, but maybe there's a better term. Yeah, it's this. Dynamic array, growable array, resizable array, dynamic table, mutable array, or array list. Okay. So that's why it's called an array list. We could call it a din array or dynamic array. I don't know. Let's see. What am I actually doing next? I actually don't remember. Let's see. You like array list over vector? Personally, yeah. I don't know. It's hard because it's kind of like programming languages calls so many different things vectors. It's kind of annoying, right? Let's see. What am I looking for? OSS Rust DSA notes. Where are we going next? We do the RawVec. We didn't do this yet, so let me do that. Maybe we do the array list next. Okay. Yeah, maybe we do an array list next. I don't think that's a bad idea. Your head is wired to alias list to linked list. Yeah. No, I get that. I mean, that's what it is in a lot of functional languages. So I'm kind of surprised that that's yours as well. But with your kind of C++ background, but maybe that's just because that's what it is in C++. I mean, most functional programmers, if you say list, they're going to assume you mean a linked list. Next time we will implement an array list on top of this RawVec. Okay. Yes, we're very excited for it. I'm going to zoom back out so I can get my freaking code thing here easier. Array list vec, stack, ring buffer, and more. Okay. I think this is pretty good. I think you forgot to add copyright at the top. Yeah. Good luck. Let's see. I think I can do this. No, of course not. Why would you actually let this work well? That's right, guys. We've got insane numbers here. Insane numbers. Okay, I just want this. And then we want to get back. We want to get back. Where are you? Okay, good. Scared me. Imagine writing that whole thing and then it just disappears. View post. Okay, I just need to copy this because that way I don't have to. It's my little thing at the end. Okay. Very good. Divider. Let's go. All right, so the main thing is to talk about layouts and then the sizes, but I feel like I don't really want to do that until I actually implement the data structure. The it seems ambiguous. Oh, okay, future highway. No, I mean, it's not interrupting. It's partly why I do this live, because I think it's interesting to get live feedback on like what's not clear. Okay, let's see. Have an Apache license on all my blog posts. Yeah. I don't care. I don't care enough, but it would be funny. Where were we talking about it here, right? In practice, unless the new size is explicitly specified, this is better. Not it will double. The original allocation will be doubled. The original. Okay, unless the. Okay, let's see. We might be able to make this simpler. So what happens when I'm going to add a sig? The RawVec has to ask the system for a new chunk of memory that is large enough to store all 6 integers. In practice, unless the new size is explicitly specified, the original allocation will be doubled. Or I could say, is that clear enough? I mean, I don't want people to think that you just double it and add it to the end, right? Unless the new size is explicitly specified, the size, I guess will just be the size of the original allocation will be doubled. Size of the original allocation will be, no, I've got it. I've got it. Unless the new size is explicitly specified, the size of the new allocation will be double the size of the original allocation. That's a lot of words, but I think it's the most clear. In practice, unless the new size is explicitly specified, the size of the new allocation will be double the size of the original allocation. Yeah, but I think I wanted it to be even clearer than that. I could have said the RawVec, but I think this is even better. Since Java has array list for den array, if you had started with C++, I think it might have been different. Yeah, I don't know. Java was my first. I mean, after the fake language JavaScript, Java was my first more real programming language, right? It was my first typed programming language. To reduce the frequency of reallocations, yeah, that's actually really good. In practice, unless the new size is explicitly specified, the size of the new allocation will be double the size of the original allocation. Oh yeah, that's nice. I like that. To reduce the frequency of reallocations. Yeah, that's nice. Okay, let's read through this, see if we want to make any more changes, and see if we want to do anything else with, like, if we want to read about layouts, maybe write a little bit about them. We'll see. Okay. I can zoom back in because I don't need the editing thing up top. Rust DSA RawVec. Implementing an array-like data structure using UNSAFE. I think that's fine. A data structure called a RawVec is used in the Rust lib. Ryan Winchester. Thanks for the raid, dude. I really appreciate it. I hope everybody's having a good time. Rare for you to do a midday stream. I noticed that. Ryan Winchester _TV. There we go. Follow Ryan if you haven't. He is the only Elixir dev on the internet. True story. The only one. That's a joke, but he does a lot of Elixir stuff. It's very good. I have the day off and was streaming, doing building design. Cool. Like a literal building. Like we're not even talking about like code at all. Unless we're talking about building codes, right? Right? Your actual house. Nice. It didn't go over well. 5 viewers. It happens. I don't know. Sometimes I get 5 viewers when I'm doing what I think's supposed to be very exciting that tons of people have said they want to watch. So it happens. But yeah, thanks so much for the raid anyway. And if the other people that came in on Ryan's raid don't know me, hi, I'm Meta or MetaMe. And occasionally I say my first name out of frustration. And we're doing a data structures and algorithms series in Rust. And right now we're doing something called a RawVec, which doesn't mean anything outside of Rust. It's just simply something, well, we're about to read about it, so you can just listen. A data structure called a RawVec is used in the Rust stdlib to provide growable raw memory allocations for use in VEC, a growable array list, and VECDEC, a growable ring buffer. Contiguous memory allocations. The most important feature of the RawVec is that it provides a contiguous memory allocation. This means if we want to store 5 i64s in a VEC, the RawVec does the job of asking the system for a memory block that will store these 5 integers in a single chunk of memory. So what happens when we want to add a 6th integer? The RawVec has to ask the system for a new chunk of memory that is large enough to store all 6 integers. In practice, unless the new size is explicitly specified, the size of the new allocation will be double the size of the original allocation to reduce the frequency of reallocations. That's a mouthful, but I still think it's a good sentence. The RawVec manages this growable allocation, so VEC doesn't have to, if that's not obvious. Comparing to linked lists. This contiguous memory block is what makes array-based data structures so fast for reads and writes at the price of flexibility and allocation. For a linked list, we only have to ask the system for an allocation large enough for the next node. In an array, we need a memory block that will fit our entire list, and in the case of a growable array, e.g. VEC, we also have to suffer the cost of resizing this memory block. We'll talk more about the details of this when we cover array list. Let's see. I kind of want to take this out actually, because I feel like we already talked about this. Above. Let me see. For a linked list, we only have to ask the system for an allocation large enough for the next node. In an array, we need a memory block that will fit our entire list. And in the case of a growable array, we also have to suffer the cost of resizing this memory block. Yeah. I mean, the order here is a little annoying, but I think I'm just going to keep it because I'm trying to not give in into any sort of perfectionism here. Implementing RawVec. The stdlib implementation of RawVec handles a broad amount of use cases. For our purposes, we will just implement a RawVec with the ability to allocate and resize. Since we're working with raw memory access and allocations, we must use UNSAFE. It looks like I did not. Did I not mark this as code? You have messages? Okay. Need to do a message check. Hold on. All right. I thought I did this already. I guess I didn't. Annoying. Okay. This looks fine. I wish they just did it a different color, the way that like other things do it. When you mark something as code, it puts it like orange or something. That would be nice, but oh well. Since we're working with raw memory access and allocations, we must use UNSAFE. We're going to talk about layouts. We're going to talk about sizes and how to deal with unsized types. And then in our summary, by encapsulating the logic for memory allocations, we can now use our RawVec as a basis for a number of data structures, array list VEC, same thing, stack, ring buffer, and more. This also allows us to reduce the amount of unsafe code in our data structures instead of re-implementing the allocation logic for each one. A little summary about the memory stuff. Next time, we will implement an array list on top of this RawVec. Okay, very cool. Yeah, so since we did this relatively quickly, I mean, it's not that many words. I'm glad we didn't take too much longer to do this. Let's see if we can talk about layouts a little bit. So let's look up the layout docs because I forget most of this and how it works. Okay, layout of a block of memory. An instance of layout describes a particular layout of memory. You build a layout up as an input to give to an allocator. All layouts have an associated size and a power of 2 alignment. Note that layouts are not required to have non-zero size, even though global alloc requires that all memory requests be non-zero in size. A caller must either ensure that conditions like this are met, use specific allocators with looser requirements, or use the more lenient allocator interface. Okay. Creates a layout describing the record for a TN on arithmetic overflow, or when the total size would exceed isize max, returns layout error. I'm pretty sure the layout array is what we're going to end up using. What's the result layout look like? Oh yeah, that's what we're on. Duh. Pubstruct layout, private fields. Very helpful. Constructs a layout from a given size and a line, or returns layout error if any of the following conditions are not met. A line must not be 0. A line must be a power of 2. Size, when rounded up to the nearest multiple of a line, must not overflow isize. So I think that's why we just use array, because array literally just gives us our types and then how many. I did not mean to click usize. So we can basically say, I need an allocation that's going to fit this many elements for this array or whatever. And I think that's kind of nice. Okay, so maybe we just playground this real quick and we can add some of this more as like a step-by-step to our blog. Oh yeah, let's go. It was beautiful, beautiful linked list implementation. All right, let's delete this real quick. And instead, we're going to say use stud alloc layouts. Okay. And then let layout equals layout array. Let's say use size. I did that wrong. Layout use size array. Actually, let's stick with I64 since that was my example below. Oh, you're right. I totally did. Yeah, let's look at that real quick. Okay. We'll put this into Rust Playground. Then we'll get back to our layout stuff. It's so bad. It's so bad because of how bad Twitch is at all this. Okay. All right. For element and this element dot right. Okay. Unsafe. Okay. Okay. Let mute array. I guess this is all going to have to be in here, right? Let's just copy that out. We'll go here. Okay. What's going to happen? Stack alloc array of arbitrary const length. Oh, interesting. I mean, I guess you would have to have a default. Well, first of all, we'd have to put a length in here. Where's maybe uninit from? Is that like a type that you wrote or something? It's in stdlib. Okay. I don't actually know this one. Maybe on init. A wrapper type to construct uninitialized instances of T. Okay. According to the requirement of the variable's type, for example, variable of reference type must be aligned and non-null. This is an invariant that must always be upheld, even in unsafe code. As a consequence, zero initializing a variable of reference type causes instantaneous UB, no matter whether that reference ever gets used to access memory. Cool. Right. I'm used to this whole thing. The equivalent code with maybe uninit, zero.assume, such as eliding runtime checks and optimizing enum layout. Okay. Similarly, entirely uninitialized memory may have any content, while a bool must always be true or false, hence creating an uninitialized bool is undefined behavior. Okay. Serves to enable unsafe code to deal with uninitialized data. It is a signal to the compiler indicating that the data here might not be might not be. Oh, that's what the maybe uninit is about. I get it now. Huh. That's cool. Interesting. Very cool. Oh, right. That makes more sense. that's probably a little bit better on a new line. Cool. Okay. So let's see about this. Yeah, if you want to put a playground together that has it working, I would do it. You can also box that up and make it heap allocated. That's cool. You get uninit-like behavior for free in C, C++. Also bugs, but we don't talk about that. Yeah, no bugs in C++, obviously. Okay, so let's just say we want 5 array 64s, right? Expected 0 generic arguments. Oh, I did do this wrong. Darn it. I had it right the first time. Is it this way? I always get this turbofish stuff wrong. Nope, we got it right. Okay, so then, and it's not like I can actually do this, but we'll just pretend. I don't think there's a debug instance for layout, but we'll just see if there is. Maybe we'll be lucky. Oh, there is. Perfect. Look at this. Layout size 40, align 8, 1, 3. Neat. Oh, hey, Infinite. What's up? Thanks for the raid, dude. Hope you're doing well. How's your project coming along? Give Infinite a little follow there. Working on a compiler, if I remember right. Let layout equals layout array, I64 5, print line layout. Cool. So What does that mean? That our 5 I-64s are going to end up needing an allocation of 40. That's because they're 8 bytes each, right? And so our size is 40 bytes. It's a little annoying. It's a little annoying that it doesn't just explain the size and align here. Like, why doesn't it do that? That would be nice. That would be nice, Mr. Rust Docs. The minimum size in bytes for a memory block of this layout. The minimum byte alignment for a memory block of this layout. The returned alignment is guaranteed to be a power of 2. Yeah. Constructs a layout suitable for holding a value of type T. Okay, so that might also be interesting to just do a layout new T. We could also do that. So maybe what we want to do is say this layout new I-64, and this should, if I'm not wrong, just give us an 8. Nice. The thing I'm forgetting is what alignment means. I'm just going to be real right now. I don't remember what align means. What does byte alignment mean again? I'm forgetting what byte alignment actually is. I mean, my guess, each memory address specifies a different byte. My guess is it's saying if I had a contiguous memory block of these data structures, each thing would be 8 bytes past the other thing, right? This was an unusual stream since you've tried to run a ramps board. Yeah, right. Okay. So I think I had it right. I mean, you used to replace a board on your ANET A3 3D printer. Next up is FP. Nice. Little floating point arithmetic. And then I will take the big goal of implementing front-end side errors. Yeah, no, totally. That's awesome, dude. It's great. More power to you. And is your compiler in Rust? I can't remember. I think it is. Size is the number of objects. Time. Yeah, I already read that. Okay. So yeah, I had alignment in my head correctly. So I think this could be interesting just to like explain this. I'm not sure what this one, like that looks like a byte manipulation thing. What does that actually mean? Align 8 1 ... 3, but maybe alignment is your compiler is in Rust. Yeah. Nice. Okay, Geo made his playground. At this point, we're just playing, but we'll check this out real quick. Okay, so we have maybe on init. Okay, okay, okay. Looks good. Let R U6425 equals make R. Nice. Very cool. Thanks for sharing. 1 n equals 2 to the nth power. Oh. So 1, 3 is 1 to the third power. Is what you're saying? No, it's 2 to the third power. Okay. Which is just to say 8. Why are they doing this to me? Why are they doing this when it really just equals 8? Are they just showing what multiple of 2 it is? I mean, it's not a multiple of 2. What power of 2 it is? I don't get the point of that, but it doesn't matter. That's because I'm not a real systems programmer at the end of the day, right? I'm just pretending to be one on Twitch. Just kidding. I'm not pretending to be one. Okay. So maybe we talk about layouts first. Implementing RawVec. Okay. In order to allocate memory, we first need a layout to provide the allocator. It's a faster way to multiply a number by 2. Oh, interesting. Using byte manipulation, right? Or whatever, bit manipulation. In order to allocate memory, we first need a layout to provide to the allocator. Since we're using the layout module provides several functions, methods to do this, including I'm going to make this a link to the docs. We just want it here. And link. There we go. Provides several methods to do this. Okay. Now we'll do a little code block with my playground stuff. And let our layouts let I layout equals layout new I64. And then this we can just make I layout. We actually can just do it the other way. I layout. And this is our layout. Let's make sure this still works. Nope, I messed up. Oh, I said RE. Okay. Nope, didn't mean to do that. Now we can copy this over to our article. Okay. Yeah, totally. No, I know that just doing bit ops are really fast. I just don't know all of them. I've never I've never learned that sort of thing very much. I haven't gotten into that sort of performance programming before. It's very cool. Respect. Okay. Why didn't, oh, I'm on the wrong playground. I was like, why isn't it here? It's Geo's playground. Okay. Here we go. So let's see. Let's just say this. And let's say this. Now, technically, that's going to say OK. I'm just going to delete the OK because it just doesn't matter that much. Let our layout equals layout array 64.5. Print line our layout. Layout size 40, line 8, 1, 3. OK. I think that this makes sense. I'm just going to change the ordering. Nope. I want a space. Oh, that's why. There we go. M and 1 equals 1. I forget. Is that the bit mask that just makes it 1 at the very end? I can't remember. I've just started getting into some of the bit masks and stuff. Yeah. And I always forget how it works. My guess is that is going to equal true no matter what you put into it, right? I just started playing with some of this through the Rust in Action book, but I don't know it that well by it's a way to test odd and even. Oh, right. Because you're just saying give me the very last right. Yeah. You're saying just give me the very last bit in this byte or whatever. Right? The std-lib implementation of RawVec handles a broad amount of use cases. For our purposes, we will just implement a RawVec with the ability to allocate and resize. Since we're working with raw memory access and allocations, we must use UNSAFE. Okay, I just read all that. I didn't need to. Odd numbers always has last bit set. Right. Yeah. Yeah, that's really cool. I know I've seen it somewhere, but I didn't know it. Let I layout. Let's see. This should just be a colon. What layout is what am I trying to say? The result. Okay. We can then provide this layout to an allocator to get the size of memory, to get, let's see, we can then provide this layout to an allocator to get the size, the amount, the size, I will say size because it's there, size of memory that we need. And then provides this layout to an allocator to get the size of memory that we need. If we are allocating a single I64, we just need 8 bytes of memory. If we are allocating an array of 5 I64s, we need 40 bytes of memory. Okay, we're going to make this size to show that it's the layout.size. we need 40 bytes of memory. Okay. All right, I think this is nice just to point out because we'll use this layout in the code. And then there's the actual allocation. And this part I don't completely remember either. Is everybody surprised that I don't remember how this works? I'm pretty sure I can just use the global allocator. This type implements the allocator trait by forwarding calls to the allocator registered with the global allocator attribute if there is one. Right. And then we just have allocate and self. And we have deallocate. And we just provide the layout. Oh, interesting. Right. Okay. Impl allocator for global. Right. So then we can actually... Oh, this is really nice. I feel like we used to have to do this manually to get the zero initialized thing. Before, I think I had to do this manually, but maybe I'm wrong. I could be wrong. So you can shrink, you can do all this. Okay. Trait implementations, alloc. Let's look at the alloc docs. Maybe it'll explain which allocator we're supposed to use. I forget. In a given program, the standard library has one global memory allocator that is used, for example, by boxt and vect. Currently, the default global allocator is unspecified. Libraries, however, like cdylibs and static libs are guaranteed to use the system by default. Like, as in system allocator. Okay. The default memory allocator provided by the operating system. Okay. This is based on malloc on Unix and heapalloc on Windows plus related functions. However, it is not valid to mix use of the backing system allocator with system, as this implementation may include extra work. Sure. This type implements the global alloc trait, and Rust programs by default work as if they had this definition. Static A system equals system. You can also define your own wrapper around system if you want. So maybe it is that we just use the system allocator. It's been a while since I've actually had to alloc in Rust. It's probably the right call. Okay. Where are the stud alloc docs again? Here we go. Layout error system, the default memory allocator provided by the operating system. Okay, so I think this is the right thing. Alloc memory with the global allocator. So maybe we just call alloc this way. Registered with the global allocator attribute if there is one, or the stud creates default. This function is expected to be deprecated in favor of the alloc method of the global type when it and the allocator trait become stable. Interesting. I don't remember what I did last time. Let's look at, instead of just looking at that, let's look at, is it the book? I want to say it's the Rust book. That has a VEC implementation. No, I'm thinking of something else, but we can go to UNSAFE Rust. Sure. Dereferencing a raw pointer. How does the book say that we should do those? This is calling an unsafe function or method, creating a safe abstraction. Do we not get any Alex in here? It doesn't allocate at all. Literally nothing about allocating in this entire book. Nice. Good to know. Oh, what was the book? What was the book that has the VEC implementation? Is it... Oh, I just can't remember. I can't remember the... Maybe it's in my bookmarks or something. I'm just going to try this because I think this is how I found it last time. No. Is it just Rust by example? I don't think so. No, that's not how I found it. Damn it. Let's look at unsafe here. No. Let's write inline and assembly instead. That's what we need to do. Okay. Well, it wasn't that. There was an example that I used in the original course. Oh, I actually wrote the code for this example in my other DSA repo. That's all I have to look up. So instead of looking at my stack implementation, which is kind of cheating, I'm going to somewhat not cheat and instead look at the source VEC here. Restonomicon. That's what it was. I couldn't remember. Really? Did they take Nomicon down? Implementing VEC. It's literally right here. Layout. Sure. We're happy with this. Allocating. I really just want to see which alloc function they call because I just can't remember which one we're going to use. Is it literally just stood alloc? Okay, it's literally what they just said. So I guess we are going to use alloc. Okay. Okay. All right. I'm glad I'm doing this now because otherwise I have to do it Wednesday and forget about it. Okay, I talked about layouts. And then this is why it's important for the type. This point also drives home the fact that we must have a sized type, a size type T in order to create a layout and eventually allocate. if we, okay. And eventually allocate. So let's make these little code guys. T layout and eventually allocate. Maybe I'm not going to write anything about alloc. We talked about unsized types. Create a layout and eventually allocate. Okay. By encapsulating the logic for memory allocations, we can now use our RawVec as a basis for a number of data structures. This allows us to reduce the amount of unsafe code in our data structures instead of re-implementing the allocation logic for each one. Rust provides some nice high-level utilities for creating memory layouts and allocations. I think that's mostly what I want to say. And maybe there'll be a little summary that comes out of the implementation, but I think this is actually pretty good. I am interested if I do this little unsafe and I say alloc, I layout. I mean, maybe this is worth doing. Do I have to put the whole thing to it? Stood alloc. Okay, fine. Stood alloc layout. Okay, very cool. So now we have this little guy P, and we can just print line P just for funsies. My mental muscle memory wasn't working there. Nice. Now we have our little place where we can put P. And then this is where we will eventually write in our vec, which could be interesting to just go ahead and do. Your memory never works. I feel that. I feel that real hard. Stud pointer YZ, assert eq, stud pointer read Y, 12. Cool. All right. So now that I actually have this pointer, this should work. Where is the right here? It takes a mute T and a source T. And what did alloc actually return? I should have just left that up. Alloc. This one. This returns a mute U size. Yeah. Okay. So I might actually have to read it first and then write it. Or maybe I can use the right bytes. Function write. Okay, I'll probably finish playing with this later. Print line P, because I think I already forgot where right comes from. Right, core pointer. Yeah, stud pointer. Stud pointer right. I don't think this is going to work. See if that works, just out of interest. Right, because this is a U8, and so that determines that type. So technically I'd have to do something like let T equals, but I think maybe it's because I can write bytes instead. Let's see. There's probably another write function that would let me do this without having to. No, this isn't what I want either. Let pointer reads to a valid bool. This function itself does not cause UB to write bytes, but then that does write bytes 1. Where'd they get this 42U8 from anyway? Let voic pointer vec as mutable pointer vec pointer 2. Okay. I just want to have the actual byte address and write to it, but I guess it doesn't work that way. It's kind of what I was hoping for. But it seems like I almost have to like read it first or something. Okay. Well, we'll get into this next time. I'm going to play with this off stream because skill issues. And that way I kind of know if I want to add this to the article, because I might want to, but I need to go for now. Thanks so much for hanging out. Thanks for watching. I hope you enjoyed it. The post will go live most likely on Wednesday. Wednesday, I will be back and will actually write the code for the RawVec, and that should be good. And so that's what's going to happen next. But yeah, I'm actually pretty happy. When I started this, I wasn't sure if the RawVec post was going to be worth writing, but I'm glad we did, because I think it's a nice like bite-sized chunk of contiguous memory. No, a nice little chunk of like behavior that we can learn if you're not used to this sort of thing, which I mean, to be honest, as it's pretty clear, I'm not that used to it either. I don't do it that much. I work with high level languages. So we're going to do some UNSAFE on Wednesday.